What is performance testing? Performance testing is a non-functional testing technique that is performed to determine the system's parameters in terms of both responsiveness and stability under various workload conditions. Performance testing measures the quality attributes of the system such as scalability, reliability, and resource usage. Why performance testing is needed? Unlike functional testing, the goal of performance testing is not to find the bugs, but to eliminate the application's performance bottleneck. The primary focus of performance testing is to check a software program's speed, scalability, and stability. Determining the capacity of existing systems by checking how much load the application can handle with the current infrastructure. Creating benchmarks for future system for finding out what is the current responsiveness of the application and use that as a benchmark for future application releases. In total, we have 8 types of web performance tests. They are baseline test, capacity test, component test, smoke test, load test, stress test, soak test, which is also known as endurance test, and finally spike test. Now, let us see what does each of these tests mean and when do we actually use them. What is baseline test and when to use it? A baseline test is the quality assurance process of running a set of tests to capture the application performance in its original state. That is, once the application is given to us for testing, we would run the baseline test to measure its current response or performance. These tests come handy when we do not have any response time agreement mentioned by the client or the stakeholders. They also become handy to compare the current application performance with the upcoming application releases. These tests help the performance testers in identifying the problem at an early stage. This will in turn give the developers a lot of time in fixing the issues before the actual performance testing starts. What is capacity test and when to use it? A capacity test is the test done to determine how many users that our application can handle before its performance or stability becomes unacceptable. This test will help us know the number of users that our application can handle successfully, and we will have a better visibility into events that might push our site beyond its limitations. These tests are very much needed for avoiding the potential performance bottlenecks in the future. What is component test and when do we use it? Testing a discrete component of our application requires a component test. For example, a chart feature, an email functionality, a file upload, a search functionality, or any third-party component like a shopping cart. Testing the component individually is very critical for application where the component is like the soul of the application. What is smoke test and when do we use it? A smoke test is a test that is run under very less load that merely shows the application works as expected. It is usually done with 5 to 10 users and is run before triggering the actual load tests in order to see if our scripts are working fine and that there is no scripting issue, or to ensure that the application is up and running. So by doing this smoke test, we can avoid any script or application related errors during the actual test run. What is load test and when do we use it? A load test consists of applying load to an application to measure the results. These tests may or may not be done at the system's maximum capacity. These tests can help determine the normal performance metrics. Additionally, by using the iterative testing, we can determine if the new code had helped or hurt the performance. For example, consider the response time of your application was 4 seconds with version 1, and when you have version 2 in place which is ready to go to production, and you have identified the response time to be 6 seconds. So this is a bad performance. So you take necessary actions to rectify that to either 4 seconds or bring it down further under 3 seconds, depending on your business needs. What is stress test and when do we use it? In stress test, we try to push the application beyond the normal load conditions. Under these extreme conditions, we can see that the components failing first and ultimately brings down the application. So after knowing those components that have failed, we can make them more robust and efficient and will help in determining the new thresholds of the application. What is soak test and when do we use it? As mentioned earlier, the soak test is also known as an endurance test. It is the long-running test that is used to determine the application's performance or its stability over time. Usually, these tests are run anywhere between 8 hours to 1 week duration and actually depends on the client's requirement. This test is very much important for those applications that are planned to run for all 24 hours in a day. For example, banking applications. The reason for running these tests is because an application may work well for an hour or two and then start to experience issues. So these tests are especially useful when trying to track down memory leaks or corruption of the system. What is spike test and when do we use it? Spike tests are usually done for identifying the application's reaction time to sudden large spikes in the load generated by the users. For example, take the flash sale of a newly launched mobile phone by any major e-commerce store. Can you imagine how many users try to get the product at the specified time? I will quote an example of OnePlus phone here. One of the major e-commerce websites announced that the sale of the phone is at a specified time, and within 2 minutes all the OnePlus phones were sold out. An estimation of sales were around 1 million copies. So we have 0.50 million users per minute accessing the application trying to get their hands on the new phone. This was only the number of users who were lucky to get this phone. There may be 3 times more users who tried to purchase the product. So using the spike test, we as a performance testers like to see what happens to the application when this additional load of users try to access it. Will it be able to withstand the user load or would it crash? Now let us see what is requirement gathering and its importance in performance testing. Before we start any of our performance testing activities, we need to have detailed information about the application. In order to get the maximum details about the application, each company has their own requirement gathering template, which consists of set of questions either maintained in an Excel sheet or a Word document. These documents will be shared with one or multiple stakeholders such as client or project manager or the business analyst. This is mainly done when we have an entirely new application to performance test. As you could see on the screen, I have drafted some of the questions that we can ask the client or include in our document that we are going to share with them. What is the application type? What is the communication type used between the client and the server? What is the user load pattern? Are there any firewall restrictions? Any preference of performance testing tool? Paid or open source? What are the key business scenarios? Are there any data dependencies? In case, if we already have a legacy system in place, we can request for the application logs or statistics of Google Analytics to know the exact peak load of the system, and we can do the workload model accordingly. However, we would still need some of the basic information from the stakeholders. Performance testing approach. Once we have all the required information through non-functional requirement gathering, we would then start drafting our test approach. This is a mandatory document on which we need the sign-off from the client or the project manager before we start with our actual testing activities. The test approach basically consists of details like application architecture, what are we testing, basically the in-scope items that we considered to include into our load tests. What are the out-of-scope items? In case if there are any, we would be providing them the exact reasons why we have marked them as out-of-scope items. How are we testing? In this section, we would be mentioning the tool that we will be using for injecting the load onto the application, whether it is a paid or open source tool. How much load are we testing with? And testing timelines. There are 5 quality aspects which we should always take care of. They are functionality, usability, reliability, performance, and supportability. Similarly, we have 3 performance quality attributes, namely performance, effectiveness, and scalability. Performance testing quality aspect. Here by performance I mean for online transactions we would be considering response time in seconds. For batch transactions we would be considering runtime either in minutes or hours, and throughput, which is nothing but items per second. Here by effectiveness I mean CPU, which is measured in real users and system time, memory usage measured in megabytes, disk usage measured by input and output, network load by package size or package count, bandwidth and latency. Here in this screen, by scalability I mean for online transactions it is the large number of users, scale in and scale out. For batch transactions we consider large transactional volumes and large database volumes. Performance testing terminologies. In this video, I will try and cover the basic terminologies that we normally use in our day-to-day office conversations, both with the clients and stakeholders. These are very important terminologies and comes in handy when we wanted to convey our thoughts to different stakeholders in the project. So let us see each of these terms in detail and what do they actually mean. Scenarios. It refers to the sequence of steps in the application under test. For example, searching for a product on your favorite website store. Workload. It refers to the mix of demands or requests placed on the application under test. It is generally measured in terms of concurrent users, data volumes, or number of transactions. Benchmark. It is the standard workload that is accepted industry-wide. We rely on two standards, TPC-C and TPC-W. The TPC-C is an online transaction processing benchmark, and TPC-W is a transactional web e-commerce benchmark. TPC-C involves a mix of 5 concurrent transactions of different types and complexity, either executed online or queued for deferred execution. The database is comprised of 9 types of tables with a wide range of record and population sizes. It is measured in transactions per minute. Coming to TPC-W, the workload is performed in a controlled internet commerce environment that stimulates the activities of a business-oriented transactional web server. Baseline. It is nothing but the measurement of an existing system's performance. For example, we have an existing version of software, and when we get a new version update, we always consider the existing version statistics to see whether the new version is a good performer or a bad performer. Concurrency. Occurrence of 2 or more events at the same instant of time is known as concurrency. In simpler terms, it refers to more than one user performing the same action. For example, searching for a product, adding the product to the cart. Think time. It is the time spent by the user between 2 consecutive requests. For example, when we try to log into our email, we enter the username and the password. Even though how much ever quicker we enter them, we still see certain time that is consumed while typing the letters. But whenever the performance testing tool that we use will work on the basis of request and response. So, if you take around 15 seconds to manually input the username and password, the prepared test script will only take less than a second to do the exact steps. So, in order to perform the realistic load on the application, we use smaller pause times after every transaction, and this is known as think times. Response time. It is the interval between user request and the system response. For example, it refers to the time between you clicked on the sign-in page and the time the server takes to show your email inbox. Reaction time. It is the time between submission of a request and the beginning of its execution by the system. Turnaround time. It is the time between the submission of a batch job and the completion of its output. Stretch factor. It is nothing but the ratio of response time at a particular load to that at the minimum load. As you could see on the screen, I have tried to provide a pictorial view of the terminologies that we have learned so far. Please pause the screen for a couple of minutes and try to correlate the terms with your general actions that you perform on any web applications. Throughput. It is one of the common terminology that we hear in our office conversation on a daily basis. It is the rate at which the request can be serviced by the application. Batch jobs. It is measured in jobs per second. CPU. It is measured in million instructions per second or million floating point operations per second. Interactive system. It is measured in requests per second. Network. It is measured in packets per second or bits per second. Transaction processing. It is measured in transactions per second. Bandwidth. It is the measure of data that can travel through a network. Usually, it is measured in kilobits per second. For example, a modem line often has a bandwidth of 56.6 kbps and an Ethernet line has a bandwidth of 10 Mbps. Latency. In network, latency is the synonym for delay and is an expression of how much time it takes for a packet of data to get from one destination point to another. In some cases, latency is measured by sending a packet that is returned to the sender and the round trip time is considered as latency. Reliability. It refers to the mean time between failure. Availability. It refers to the mean time to failure. Cost. Amount of money involved for hardware or software licenses, installation and maintenance is called as costs.
Some of the basic questions that we can ask during the requirement gathering phase are: what is the purpose of the system? Details of high-level activities that the users can perform on this application. How often each activity is performed. Which activity is frequently used and are they resource intensive? Hardware and software architecture. Production architecture. If the application is already in production, what are the current response times and throughput? Are there any requirements for the data preparation? What is the desired norms for the resource utilization? What is the available percentage of test environment for carrying out our performance testing activities? Over this screen, we will try to know where we can get the information that we needed for our requirement gathering. Though we do not perform any functional testing, we should have thorough knowledge about the application that we are going to test. So we can contact the following people for having the necessary details about the application that we are going to test. It can either be the client or the stakeholders, project managers, technical or application architects, business analysts, or from the documentations like user guide, technical design, etc. Now let us see more about performance test plan and its contents. Project description. It has details about the project introduction and details regarding like how it is going to benefit the end users. Project scope. Since we are submitting this test plan for client approval, we would be including our in-scope items and out-of-scope items in this list. Entry criteria. Before we start any of our testing activities, we make an agreement with the project manager on some critical items such as all found defects during the system testing phase has to be fixed and retested. Code freeze is to be in place for the application and configuration is frozen. The test environments are ready. Master data has been created and verified. No activities outside performance testing and monitoring will occur during the agreed time period. So all these items will fall under the entry criteria. For the exit criteria, we have few pointers like all planned performance tests have to be performed. The performance test passes all stated objectives at the maximum number of users specified. The application overview gives a description about the business purpose of the web application. This may include some marketing data stating estimates or historical revenue produced by the web application. The architecture overview contains the details about the current architecture that we have for our application. Performance testing process includes the description of user scenarios, the performance testing tool that we will be using for injecting the load, user ratios and think times, a ramp up and ramp down pattern. The test environment includes details about testbed that describes more about test environment to be used and its availability. Network infrastructure contains details about the network topology. Hardware resource contains details about memory, processor, environment, and test data details such as database size and other test data requirements. Under the key stakeholders and their responsibilities, we have a list of people who would be helping us whenever we need some information or if we are blocked with some activity. For example, if we are having a development issue, we would be having a developer lead details whom we need to contact for fixing that bug on a priority so that there will be no impact on our performance testing. Project schedule. This contains the timelines that we have for performance testing, and it is given in different formats. Risks and dependencies. This is an important concept in performance test plan. In this section, we would be updating the risks that we have for completing our testing and the dependencies that we have. Say for example, the test data needs to be prepared and be in place for performance testing. So all these kind of risks and dependencies that we foresee for completing the project are mentioned here so that the project manager and other stakeholders can look at it and complete them so that there will be no blockers for performance testing team to carry out their activities. Status reporting process. Under this section, we would be mentioning, like, after completing each load test, what is the result format that we are going to share and whom we are sharing this report with and whose approval is needed for closing the test results. So all these details would be mentioning under the status reporting process. A performance testing script consists of correlations, parameterization, transactions, rend-US point, and verification checks. Correlation is done to resolve dynamic server values such as session ID or cookies. Most of the commercial performance testing tools support both manual and automatic correlations. Parameterization is done to provide each user with unique or specific value for applications. Depending on the parameter type that is set in our scripts, the values are dynamically provided by the tool to each virtual user in order to perform the real load test. Transactions are defined to measure the performance of the server. Each transaction measures the response it takes for the server to respond to a specific virtual user request. Rend-US point. They are used to synchronize virtual users to perform a task at the exact same moment to emulate heavy user load. When a virtual user arrives at a rend-US point, it is held by the controller until all virtual users participating in the rend-US reach that point. Verification point like text check and image check are used to make sure that the script is successfully navigating throughout the workflow. If an error occurs in between, through these verification points, we could know exactly where the script is failing. Test checks are usually done in most of the web application scripts, whereas image checks are added to the script where the end user decides whether to buy or not to buy a product by looking at the images. For example, Amazon.com. Before proceeding with the performance test execution, ensure that the test system is up and running. You can check this by manually triggering the launch URL of the application. Check if all the test data required for completing our test is in place or not. Check if the system configuration is as per the plan. In case if you are not aware of this, please check with the middleware team for confirmation. Perform a smoke test to ensure that the scripts are working fine. Check if the scenario scheduling is correct with the accurate ramp up and ramp downs. Ensure if the schedule is correct to groups and if the number of virtual users for each group is correct for the test run. Double check if the monitoring tools or utilities are ready to collect the performance data. Lastly, always ensure that the debugging statements in the scripts are commented and logging is done only when necessary. This will avoid unnecessary piling up of log file and sometimes crashes our load test if it is planned to run with huge number of users and for longer duration. Performance test metrics collection. As performance testers, we should not only concentrate on the application response time, but we should also keep a watch on the metrics during the test run. Depending on the project, we may or may not get an application performance monitoring tool such as App Insights, App Dynamics, or Dynatrace. If the project does not have the required budget to invest in the application monitoring tools, we may need to do the monitoring the manual way using perfman, system commands, etc. For the client-side metrics, we should mainly concentrate on response time and throughput provided by the test tool. For server-side metrics, we would mainly rely on perfman for Windows, system commands for Linux or Unix, free test monitoring tools, JMX counters, application server logs, database server logs, and web server logs. Performance test result analysis. Always remember that with respect to the response time, the lesser time it takes, the better it is for the application performance. With respect to the throughput, it is always better to have their numbers on the higher side. As you could see on the below screen, throughput increases as load increases and reaches a saturation point, beyond which any further load increase will also increase the response time exponentially. This is called the knee point or the application saturation point. Performance test result analysis. User load versus CPU utilization should always be linear. If 100% CPU usage is reached even before the expected user load, then CPU is the bottleneck. To overcome this issue, do a quick check by increasing the number of CPUs or by using a faster CPU. Also check for some context switches on processor queue length. If 100% CPU usage is not reached, then check for bottlenecks in other system resources. Load versus disk input and output. Check for average disk queue length and current disk queue length. Check for percentage disk time. Also check for disk transfers per second and see if you can find any issues. Memory utilization versus time. Check for available memory and amount of swapping. Memory usage should get stabilized after some time into the test. If memory usage increases with each test run for each iteration of an activity for the same amount of users and does not come out, then it could be a possible indication of memory leak. For network utilization, keep a check on current bandwidth, packets per second, packets lost per second. Performance test report creation. It is the end deliverable of performance testing and is very important from stakeholders' point of view, as their decision to go live or not to go depends on our test results. It should reflect the performance test objective. Always ensure to provide the test results in a tabular format and add the relevant graphs to it. Include a note of all the issues faced during the testing. Document all the findings and observations. Load and especially stress tests would sometimes reflect the bad side of an application. So when it throws error, capture all of them for future analysis. Share the recommendations to fix it and rerun the test again to see if it is still throwing errors or if it is fixed. Any deviations or workarounds should be mentioned in the test report. Conclusions should be substantiated with proper analysis. The test result report should contain executive summary, test objective, test results summary, conclusions and recommendations, test environment setup, software configuration used including major and minor versions wherever applicable, hardware configuration, business flows or test scenarios tested, test run information including observations, test results in tabular format and their relevant graphs, conclusion and recommendations.
Here is the list of important aspects to watch for whenever our tests are being executed. From the software performance side, we need to look at the application code. In case if you are not a developer, we can speak to the relevant stakeholders and have the latest code deployed into our testing environment. Secondly, we need to look at the configuration of servers and operating systems. From the hardware performance perspective, we need to look at CPU, memory, disk utilization, and network statistics. What are the performance counters and why are they important? Performance counters actually help you track down the performance of the application. For client-side metrics, we would be looking at the response time, hits per second. The hits per second graph shows the number of hits on the web server on the y-axis as a function of the elapsed time in the scenario on the x-axis. Hits per second graph can be compared to the transaction response time graph to see how the number of hits affect transactions performance. Throughput. Pass-fail statistics. It gives the measure of application capability to function correctly under load. It is measured by measuring transactions pass, fail, and error rates. For server-side metrics, we would be looking at for CPU, percentage of user time, percentage processor time, run queue length. For memory, we will be looking at available and committed bytes. For network, we would be looking at bytes sent per second and bytes received per second. For disk, we would be looking at read bytes per second and write bytes per second. What is workload modeling? As per the definition, workload model is the mix or combination of requests placed on the application under test at a given point of time. It is the stimulus to the system. Designing workload model is a critical and mandatory activity before we perform any load or stress testing. It helps us to study the behavior of the system under various identified workload models. A request may include things such as authenticating a user, performing calculations, retrieving data from the databases, transforming the data, or sending documents over HTTP or HTTPS protocol. Importance of workload modeling. Workload may be no load, minimal, normal, above normal, or extreme load conditions. Extreme loads are used in load or stress testing. This is done to find out the breaking point of the application and to identify the bottlenecks. Minimum loads are usually used in benchmark testing in order to estimate the user experience. Normal loads are used in performance testings in general. This is done to ensure acceptable level of performance characteristics like response time or request processing time under the estimated load. Workload is identified for each of the scenarios. It can be identified based on the following parameters. Number of users. The total number of concurrent and simultaneous users who can access the application in a given time frame. Rate of request. The request received from the concurrent load of users per unit time. Pattern of the request. A given load of concurrent users may be performing different tasks using the application. Patterns of request identify the average load of users and the rate of request for a given functionality of an application. Workload models. Now let us see each of the workload models in detail. Steady state workload model. It is the simplest workload model used in load testing. A constant number of virtual users are run against the application for the duration of the test. Below is the diagram showing the basic steady state workload model. Increasing workload model. It helps testers to find the limit of the web application's work capacity. At the beginning of the load test, only a small number of virtual users are run. Virtual users are then added to the workload step by step at regular intervals of time. Below is the diagram showing the basic increased workload model. In steady-state dynamic workload model, you can change the number of virtual users in the test while it is being run. And in this workload model, no simulation time is fixed. Below is the diagram showing the basic dynamic workload model that we use in performance testing. What is workload profile? A workload profile consists of an aggregate mix of users performing various operations. Workload profile can be designed by performing following activities. Identify the distribution or ratio of work. For each key scenario, identify the distribution ratio of work. The distribution is based on the number of users executing each scenario. Identify the peak user load. Identify the maximum expected number of concurrent users of the web application. Using the work distribution of for each scenario, calculate the percentage of users. Identify the user load under a variety of conditions of interest. For instance, you might want to identify the normal user load and the peak user load of the application. Consider a sample web application where the distribution of load for various profiles could be similar to that shown in the below table. We have identified 3 different scenarios for performance testing. Some of the users would be browsing the application, some of them would be searching for a product, and the remaining users would be buying the product. And the total number of users that we have identified for this test is 200, and the test would be designed to run for 2 hours. There is a random think time between 1 to 10 seconds is given in the test script for after each operation. What business flows to include in performance testing? Decide on the business flows that needs to be included in our testing. Once we have the list of scenarios that we wanted to include, we will schedule a call with the stakeholders to get their approval. If they feel anything needs to be modified, we can change it until they agree on the list. Once we get the go-ahead, we then add the list to the test approach and send that to the client or stakeholders for their approvals. Decide on the mix of business flows in the test run. Similarly, if we have any specific script that needs to be run in isolation, we need to get an agreement from the client here. For example, if they prefer testing only the new functionality that they added as part of this new release. Decide on the order of test scripts that needs to be started. This happens at extreme rare cases wherein we need to execute one set of test script first so that the generated data can be used in the next set of scripts. For example, if you have 2 scenarios like purchasing a product and cancelling that product order. So, we have to run the purchasing order script first and then use the purchasing order number in the second script to cancel that order. Decide on the ramp up for each business flow and test duration. If we want, we can combine all the scenarios and have a generalized ramp up and ramp down, or else we can have a different workload model for each scenario. This entirely depends on the business requirement. As you could see on the screen, it shows the graphical representation of performance engagement process. New project query, response over requirement questionnaire, signing the contract, approving the test plan, providing application demo, providing written approval on business flow document, and providing the feedback on the closure report were the tasks of the project team. Sending the requirement questionnaire, preparation of the test plan, business flow document creation, creating project plan, creating test execution and reporting results are the tasks of the performance testing team. I suggest to pause the screen for a minute or 2 and see what are the deliverables that are expected from the performance testing team and what are the activities that needs to be performed by the project team. Performance test process is divided into many phases, namely initiation phase, planning phase, designing phase, execution phase, and reporting phase. As you could see on the screen, the activities and deliverables highlighted in orange color in each of the phase are to be taken care by the project team. The activities and deliverables mentioned in blue color are the responsibilities of the performance testing team. I suggest to pause the video for a minute or 2 to understand each of the team's deliverables and their roles. While gathering the performance testing requirements, we need to take special care about the test objective. It forms the basis of deciding what type of performance test needs to be done. The test plan and test report should reflect this objective. Performance requirements. It shows the expected performance levels of the application under test. Performance absolute requirements. It includes criteria for contractual obligation, service level agreement, or fixed business needs. Performance basic goals and objectives include criteria desired in the application, but variance in these can be tolerated under certain circumstances. Resource constraint. This is to ensure if we will be given the testing environment dedicatedly for carrying out our performance testing activities, or do we need to share the environment with any other teams. How to gather the performance testing requirements. Whenever the company receives a request for performance testing an application, the company sends their own standard template of requirement gathering questionnaire to the project manager or the client to understand more about the application that they are going to test.